There are a number of ways of converting the Monarch 10EE to AC drive, and probably the most common method is utilizing an AC motor and machining an adapter plate which bolts to the face of it, which then the back gearbox from the lathe can bolt directly to that. Now that will mean that you need to extend your motor shaft, so you have to take the motor apart, extend the shaft. Not a huge ordeal. I lucked out in that the motor that I chose, the outside diameter is pretty narrow, so it happens to fit really well in the lathe. So I'm going to take the approach of utilizing the back gearbox connected to its original bell housing and then mate that whole assembly to the AC motor. So to do that, we need to make an adapter plate that'll connect the bell housing to the motor, and that's what I've done here. This is a 1-inch thick plate machined from 7075 aluminum. It's got a counterbore on both sides with a very nice snug fit to the face of the motor as well as the bell housing itself. And so follow along and I'll show you how I made that piece, and then we'll continue on with the other steps. Okay, let's get a measurement, see where we're at. Okay, we're right at 1,460. So we've got about 32 thousandths left to go. So it's pretty warm right now. I'm gonna let that cool down, then we'll do our finish cuts. Okay, well here we have the finished outside diameter work on the bearing holder, and it turned out really nice. The surface finish is perfect. The size is on size to the 10th, which is pretty amazing for an old 73-year-old South Bend using carbide tooling. The inserts I'm using are Cermet Hertel brand that I buy from MSC. They're CCMT, and the size is 32.50.5, so about an 8,000th nose radius, I believe. And with the right speed and feed on this old slow South Bend, turns out great. So we hit our number to the 10th, and we're ready to flip it around and do the bearing bore. Now that we have our bearing holder finished up and we have a new oil seal and our fasteners, we need to push the new seal in, press in the carrier, and bolt it from the other side, and the bell housing will be complete. Okay, we have the bearing carrier installed now, and this is what it looks like from the gearbox side. This is the mating surface here, locating pin. We have our fasteners, and here you can see the oil seal where the new axle extension or motor shaft extension will run through. And from the other side, we have that. Okay, I've reinstalled the bell housing so you can get a better understanding and perspective of the bearing carrier that we've been making in relation to the motor shaft itself. So now we need to make the shaft extension, which will run from the motor shaft through the bearing into the back gearbox. It's 1.1 inch on the motor side, 1 inch on the gearbox side. It will take a measurement from the surface of the bearing, the face of the bearing, to the shaft here, and subtract about maybe 10 thousandths for clearance. And the shoulder created by the two different dimensions here will create a nice thrust surface too. Not that I think it needs it, but it can't hurt. There's not a whole lot of axial load or radial load for that matter. So that's where we're at.